Hey guys, welcome back to Geometry. Mr. Delora here, and today I have another review of some algebra concepts that you guys have learned in years past. Today is a pretty important one, solving equations. Throughout the course of our year in geometry, we're constantly going to be solving equations. We're going to be looking at finding the value of the variable that makes an equation true. So let's start off by jumping into the definition of equation. An algebraic equation is simply two mathematical expressions that are set equal to each other. In other words, there's going to be an equal sign in that algebraic sentence. The additive inverse is the number x such that when you add it to another number, the result is 0. So for example, the additive inverse of positive 5 is simply negative 5, because when I combine 5 and negative 5, my result is 0. Whereas the multiplicative inverse is the number x such that when multiplied to another number, the result is 1. These numbers are also known as reciprocals. So, for example, if I have 5, the multiplicative inverse of 5 is 1 over 5. Because when I multiply 5 times 1/5, my result is 1. And these are known as reciprocals. That's a pretty poor one there. Sorry about that. All right, inverse operations. Now, this is all leading us up to what are some inverse operations, because these are the operations that we use in order to solve equations. Well, the inverse operation of addition is simply subtraction, and therefore the inverse of subtraction is addition. You're probably led to believe that the inverse of multiplication then is division. The inverse of division is multiplication, and then finally the inverse of squaring is taking the square root. So those are our basic operations that we're going to be using this year, and their inverses. Now, some algebraic properties that allow us to solve equations for variables are the addition property of equality and the multiplication property of equality. And they simply state this, that when I add the same number or the same quantity to both sides of an equation, it's going to keep the equation in balance. In other words, if two things are already equal, like A and B, and I add C to both A and B, then they're going to remain equal to each other. And that's essentially how you can think of an equation. It's like a balance, that two sides are equal. When we want to try to get something alone on one side, we have to move things over to the other side. Therefore, we have to do even things or equal things to both sides of the balance in order to keep it in balance. The multiplication property of equality is simply multiplying the same amount to both sides of an equation will keep the equation in balance. So, in other words, if two things start off being equal to each other, like A and B, and I multiply the same amount to both A and B, then they are going to remain equal to each other. Now, when I want to solve for a variable, this means I want to find the value of the variable that makes that statement or that sentence true. So let's do some examples here of solving equations. And I'm going to use some of the terms that we just learned. Here's an equation that says k minus 9 is equal to 12. This is an equation. There's an equal sign. Now, in order to solve for the variable k, I need to get k by itself. So on this side of the equal sign, I have k that's being subtracted, that we're subtracting 9 from k, and over on the other side I have 12. So what I want to do to get k by itself, to get that amount k alone, is I want to add 9 to it. So if I have k minus 9 plus 9, that additive inverse is going to bring k by itself. Now, what I do to one side of the equal sign, remember, I have to do to the other side in order to keep these two sides balanced. So 12 plus that 9 is going to give me a result of 21. And therefore, the value of k is 21. All right, if I move to the right here, this next example, I have 18 is equal to 2 times some number plus 6 more. Now, this is going to be known as a two-step equation, and I want to solve for x. In other words, get x by itself. So if I have 2 times that x value plus 6 more, I want to start by getting 6 over to the other side of the equal sign. So I'm going to subtract 6 from both sides. And this is going to keep it balanced. In other words, now 2 times that variable x is going to be equal to 18 minus 6, which is 12. Now, again, I have 2 times some value is equal to 12. So in order to undo that multiplication, I'm going to divide both sides by 2. when I take 2 and divide it by its multiplicative inverse there, or I should say multiply it by its multiplicative inverse, 1/2, the result is going to be x, and 12 divided by 2, it's going to equal 6. So my value for x should be 6. Now there's an easy way to check and see if you are correct. Simply take that value of 6 and plug it back in for your variable. And then follow your order of operations. 2 times 6 plus 6. That gives me 12 plus 6, which is equal to 18, and that's what my sentence stated it was equal to. All right, letter C for these examples says t, my variable, some number divided by 4 minus 9 is equal to 11. So again, I want to solve for t, get t by itself. So I'm going to start by adding 9 to both sides. And now this is going to allow me to have t over 4 is equal to 11 plus 9, which is 20. Now I'm going to multiply both sides because this is saying t is being divided by 4. I want to take the inverse operation of that, which is multiplication. I'm going to multiply both sides by 4, and that's going to give me just t by itself, and that's going to result in 80. So t is equal to 80. All right, our final example here for our solving is pretty complex. I have more than 2 steps. In this case, I also see that I have a parentheses with a number in front, which reminds me I need to distribute that 2 to both of the terms inside the parentheses. So I'm going to start off by simplifying this right side of the equation, and this is going to give me 12y minus 8. So now I have 24 plus 3y equals 12y minus 8. I have an expression with y on both sides of the equal sign. So I'm going to start by combining those like terms. And what that means is I'm going to move the 3y over to the right side, and I'm going to do that by the inverse operation of addition, which is subtraction. So that leads me to 24 is equal to 12y minus 3y is going to give me 9y minus 8. All right, now remember my y's reduced to 0 on that left side. Now I'm going to add 8 to the left side of the equation, and that's going to give me 24, plus 8. I said subtract, I meant plus, or add. So 24 and 8 is going to result in 32 is equal to 9y, and my final step is to divide both sides by 9. And that gives me a value for my y. In this case, we're just going to leave it as 32 over 9. That's a fraction answer, and that's completely fine. All right, in our last few examples for today, we want to convert the English into an algebraic equation or sentence. So learning to convert that English to math is a really important task for us this year. 1/4 of some number is equal to -8. Now, whenever we see that is equal to, we know that we can drop our equal sign into that equation. -8 is simply going to be -8. Now, 1/4 some number. Whenever we read this some number, we know that we have a variable. So 1/4 of that is simply 1/4 multiplied to that variable. So we can say 1/4 x equals -8. I would like for you to take a minute, pause the video, and solve this equation for the value of x. Welcome back. Here we go. Our next one is 3 less than 10 times the number is 21 more than 6 times the same number. Now notice that we don't have the equal to, but we have the is. Is represents our equal sign. So we're going to break up our equation into 2 sides. Now we have 3 less than 10 times a number. A number, we don't know what it is, that's going to represent our variable, and we can use the letter x or any other letter in the alphabet as well. 3 less than means we're going to subtract 3 from that 10 times a number. So 10x minus 3 is 3 less than 10 times some number. Is 21 more than 6 times the same number? So we are going to multiply that same number, which is our variable x, by 6, and add 21 to that. All right, example 2, I'd like for you guys to pause the video and try these examples out on your own. All right, take a second to unpause that video and check your answers. How did you do? We'll see you tomorrow in class.